morning. This is the very last part of this chapter. It's lesson 10.8, and it actually finishes the last of all the quadratic equations lessons that we have in this book. In this last section, we're going to spend time comparing linear, exponential, and quadratic models. Sorry, my handwriting is a little bit messy there, but you get the picture, and it'll be clearer once I do all of the graphs. Okay, so I'm going to draw a series of 3 graphs here. I'm hoping you can see that more clearly. Three coordinate systems, one for each kind of function. And I'm going to start with a linear function just as review, and this should be something you guys remember. A linear function. If I told you to tell me what is the basic equation for a linear function, I think most of you would tell me, if I draw a line, that function name is y equals mx plus b, where m is the slope and b is the y-intercept. Now that's not the only equation we've used for linear equations. We've also talked about standard form and point slope, but slope-intercept is usually the most commonly known. The next kind of equation we have is exponential. Slightly longer word. And that equation is known as y equals a times b to the x. You remember that? We did that a few chapters back. And the third is the one that we just did in this chapter. And that is, and actually not this chapter, chapter 9 and 10, is the quadratic. And that one has the form y equals ax squared plus bx plus c. And I forgot to draw my exponential equation. My exponential equation goes like that. And my quadratic equation, as you know, goes like this. Okay. So that's what each of these functions look like, but we need to learn how to recognize them if we're given a set of data. And that's part of what this chapter is about. The first half, we're going to start to identify it from the data, and the second part of the chapter, we'll actually start writing an equation from the data, which is something we've done before. Okay, so in all cases, I'm going to draw a table. And I'm going to use the same x values for each type. So my x values are going to be -4, -2, 0, 2, 4. -4, -2, 0, 2, 4. And my y values for each, in a linear function, I have just 1, 2, 3, 4, 5. In the exponential function, I have 1 over 32, 1 over 8, 1 over 2, 2, and then 8. And then the quadratic, I have 5, 2, 1, 2, 5. Now, if all I did was present you with this data, how would you know what function is which? Well, if you look at this first one, for every change in 2 for x, there's +1 for y, right? So the change of y over the change of x is constant, which means that that's my slope. So if the difference between the first and second term as they increase, right, is the same at each point for the given change in x, it is a linear equation. For every 2 x's, you've got +1 in y, and that identifies it as linear. Now let's look over here. Now here, if I go from here to here to here to here, from 1/32 to 1/8, I am multiplying by 4. Here in a linear equation, I'm adding. But with an exponential equation, if you remember, we're multiplying. And that is what identifies it as exponential. So far, this is not new. You've seen all this and we've done it together. The only new part of this, and I'm gonna star it right here so you pay special attention, is the quadratic. Besides the fact that you can see that the y's are going down and then coming back up, which is basically exactly what the quadratic function does, you can also identify it by the differences. So if you look from 5 to 2, and 2 to 1, and 1 to 2, and 1 to 5, you're going to get 3, a difference of 3, right? And then a difference of 1, and then here a difference of -1, and a difference of -3. This is called the first difference. But with a quadratic function, you also look at the second difference. The difference between 3 and 1 is 2. 1 minus -1 is 2, and -1 minus -3 is 2. And so this is quadratic because with a quadratic equation, the second differences are all the same. So the second differences are all the same. That is how you identify a quadratic equation. So looking back over it, a linear equation is identified because for a given change in x, the change in y is +1, +1, +1. It's an addition of +1, or it could be +3, +4, but it's constant. With an exponential equation, it is not an addition or subtraction, it is a multiplication. You're multiplying by 4 or you're dividing in the case of an exponential decrease. And then with a quadratic equation, you can look and see the general shape of the curve, but you can also do the first differences and then the second differences. And if you find the second differences are all equal, you can say for sure that this is a quadratic equation. I'm going to stop here with the introduction, and next I'm going to do the first examples that relate to problems 8 through 11 on the homework.